Dear students, in our previous lectures of haloalkanes and haloarenes, we have done classification of haloalkanes and haloarenes and nomenclature and isomerism of haloalkanes and haloarenes. Now today we will be doing the general methods of preparation of haloalkanes. This is supposed to be a very important lecture because it will recapitulate the certain concepts that were done in the class 11 and will take us ahead towards the new concept also. Now, for the preparation of haloalkanes, first method of preparation is from alkanes. Remember, this was the property of the alkanes and here it becomes the preparation of haloalkanes. Mechanism of this reaction was free radical substitution reaction mechanism. If you remember, we did free radical substitution reactions in class 11. Now, try to recapitulate, we have done this reaction in the class 11. When alkanes, how do we represent alkane? RH, are treated with halogens like chlorine, bromine or iodine in the presence of sunlight or photon of energy. This RH bond will be cleaved and it will be substituted by chlorine free radical in this reaction. So it will result in the formation of alkyl chloride. As for example, if you look over here, methane, when react with chlorine in the presence of sunlight, what is formed? Methyl chloride and HCl. We did in class 11. What is the mechanism of this reaction? Free radical substitution reaction mechanism. Try to revise your class 11th work. And whenever the reaction intermediate is a free radical intermediate, we know the stability of free radical 3 degrees more as compared to 2 degree as compared to 1 degree free radical. As for example, if we consider this reaction, CH3, CH2, CH3. This is 1 degree, this is 2 degree, this is 1 degree. If it is treated with a halogen in presence of photon of energy or sunlight, there are two probabilities that the free radical may substitute on 1 degree or the free radical may substitute on 2 degree. But since 2 degree free radicals are more stable than 1 degree, so major product will be 2-chloropropane. So 2-chloropropane will be the major product. Why? Because 2 degree free radicals are more stable as compared to 1 degree free radical. Now, this halogenation of alkanes result in the formation of haloalkanes. The reaction can be easily carried out with chlorine. As we did in the class 11, reaction with bromine is slow and reversible. While with iodine, the reaction is reversible. So, to prevent the reversibility of a reaction in iodination, it is to be carried out in presence of oxidizing agent like HiO3 or HNO3, which oxidizes hydrogen iodide so formed into free iodine and hence prevent the reversibility of a reaction. So how do we carry out the iodination reaction? Methane plus iodine form methyl iodide and hydrogen iodide. It is carried out in presence of oxidizing agent so as to convert hydrogen iodide into free iodine. This was the first property or a chemical property of alkane, that was halogenation. What was the mechanism? Free radical substitution reaction mechanism. What is the stability of free radical? 3 degrees more as compared to 2 degree as compared to 1 degree. So all answers were regarding this method of preparation of haloalkanes will be based on stability of a free radical. Now, second method of preparation is from alkenes. This again is the reaction which is being done in the class 11 and this was the property of alkenes. Alkenes undergo what reaction? The general reactions of alkenes are electrophilic addition reactions. So here the mechanism of the reaction will be electrophilic addition reaction over here. So by electrophilic addition reaction, alkenes will add to halogen acids to form alkyl halide. As for example, ethene molecule when react with hydrogen bromide, this is electrophilic addition reaction. H will add over here, Br will add over here. The addition of electrophile takes place in the slowest step. So it is an electrophilic addition reaction. It will result in the formation of a ethyl bromide, or we may call it as 1-bromoethane. Now, as far as electrophilic addition reactions are considered, try to recollect what was the reaction intermediate? Carbocation. And the stability of carbocation 3 degrees more stable as compared to 2 degrees as compared to 1 degree. Just see over here, such as propene, when react with HBr, what will be the reaction intermediate? 2 degree carbocation. When unsymmetrical reagent adds to unsymmetrical alkene, Markovnikov rule will be followed. So this Br will go to that carbon atom which is more stable. So answer will be 2-bromopropane. Which rule is followed over here? It's the Markovnikov rule. So when we carry out electrophilic addition reaction, we must remember Markovnikov rule. However, to propene molecule, if HBr is added in presence of peroxide, anti-Markovnikov rule will be followed, and this negative part of the reagent will go to that carbon atom which contain more number of hydrogen atoms. So what will be the answer over here? It will be 1-bromopropane. So remember, when two alkenes, halogen acids like HBr, HCl or HI are added, it will always and always result in the formation of haloalkanes. When to the unsymmetrical alkenes, unsymmetrical reagents are added, the Markovnikov rule will be followed, and when the addition takes place in presence of peroxide, anti-Markovnikov rule will be followed. What is the mechanism of the reaction? Electrophilic addition reaction mechanism. What are reaction intermediate? Carbocation. What is the stability order of a carbocation? 3 degree will be more stable as compared to 2 degree as compared to 1 degree over here. Now, to alkenes, if halogens are added, then there are two specific cases in this case. How to prepare allyl chlorides or allyl halides. Remember, I told you in the beginning of the lecture, the question in this chapter will be related to certain structures, and one of the structure in those discussion was allyl group. Now just see over here, this is propene, CH3, CH double bond CH2. To propene molecule, when chlorine is added, just see the difference. Over here, the temperature is mentioned. It is 1773 Kelvin. So this is allylic substitution reaction. Remember, here addition is not occurring. The substitution reaction is occurring on this alkyl group. So this is allylic substitution reactions over here. So what substitution reaction over here? These are allylic substitution reactions. Just see over here, to propene molecule, when chlorine is added at 773 Kelvin, halogen atom substituted alkyl group in place of by removing hydrogen atom from there, and will result in the formation of allyl chloride. So what is formed over here? This is allyl chloride is formed over here. Fine. Similarly to the propene, if N-bromosuccinamide is added, NBS is N-bromosuccinamide. This is a structure, CH2CH2, COCO, MBr. This also favors allylic bromination reaction. So to propene molecule, when NBS is made to react, bromine from here will substitute at CH3 group by removal of hydrogen atom and will form allyl bromide. So what is formed over here? It will result in the formation of allyl bromide. What will be the mechanism over here? Free radical substitution reaction mechanism. If you try to clearly understand the concept, by now we have revised this reaction from class 11, which is free radical substitution reaction. We have done this reaction from the class 11 again. Both the reactions were done in the class 11, and this was electrophilic addition reaction. In free radical substitution reaction, intermediate was free radical. The stability of free radical 3 degrees more as compared to 2 degree as compared to 1 degree. In electrophilic addition reaction, reaction intermediate is carbocation, and the stability of carbocation is 3 degrees more as compared to 2 degree as compared to 1 degree carbocation. Now, these are two specific cases. These are allylic substitution reactions over here. Both these reactions were also done in the class 11 as a free radical substitution reactions. Now the third method of preparation of haloalkane is from alcohol. This is a new reaction we are studying in the class 12. Mechanism of this reaction will be nucleophilic substitution reaction mechanism. Although the mechanism will be discussed in further lectures, but let us first of all understand this method of preparation of haloalkanes. Just see over here. This is alcohol. This is halogen acid. So this reaction in the further discussions will become property of alcohols. Here it is a method of preparation of haloalkanes by nucleophilic substitution reactions. As for example, these alcohols, when made to react with halogen acid, HX can be HI, HBr or HCl. This bond will be cleaved from here, RO bond, and here this X will be substituted over here. X over here will be a nucleophile. So product obtained will be Rx and the water molecule will be given out. What mechanism? Nucleophilic substitution reaction mechanism. The detail of this substitution will be discussed later on in the chapter. However, always remember, in nucleophilic substitution reaction, intermediates are carbocation and the stability order of carbocation is 3 degree will be more as compared to 2 degree as compared to 1 degree. So what will be the order of reactivity of alcohol with halogen acids? 3 degree is more reactive as compared to 2 degree, which again will be more reactive as compared to 1 degree. Now just see an example over here. If you take ethyl alcohol when made to react with HCl in presence of anhydrous zinc chloride, this OH will be substituted by Cl and will result in the formation of ethyl chloride. Cl is a nucleophile. It has substituted the OH group. So mechanism will be called as the nucleophilic substitution reaction mechanism. So alcohols are converted to haloalkanes. And always 3 degree alcohol reaction will be faster as compared to 2 degree as compared to 1 degree. Why? Because the mechanism involves the reaction intermediate carbocation. And during this substitution reaction, when this bond is cleaved, we will get a carbocation. In this case, as for example, we will have 3 degree carbocation. And this 3 degree carbocation will be more reactive as compared to 2 degree carbocation as compared to 1 degree carbocation. And depending upon the stability of a carbocation over here, definitely I can say 3 degree alcohol will be reacting more quickly as compared to 2 degree alcohol as compared to 1 degree alcohols over here. So just see, first method was property of alkanes and the preparation of haloalkanes. Second was property of alkenes and the preparation of haloalkanes. Third is property of alcohols and it is a method of preparation of haloalkanes over here. So haloalkanes can be prepared from alcohol also. And the first way was when alcohol was made to react with halogen acid. It resulted in the formation of haloalkanes. 3 degree was more reactive as compared to 2 degree as compared to 1 degree on reaction with halo acid. Now from alcohol, we may prepare haloalkanes by reaction with SOCl2. SOCl2 is called as thionyl chloride. So alcohol when react with thionyl chloride, the CO over here, in presence of pyridine base, it will result in the formation of alkyl chloride plus HCl and sulfur dioxide. Now the two questions are generally asked in the board examination. What is the function of pyridine over here? Pyridine, as we all know, is a base. So this base will react with HCl, which is an acid, and neutralize it, and hence favors the reaction to shift in the forward direction. So the question that will be asked in this case will be, why do we use pyridine? It will neutralize HCl so form and favor the forward reaction. Secondly, sulfur dioxide is a gas and it will escape out. So by this method of preparation from alcohol, maximum yield of haloalkanes are obtained. So as far as preparation of haloalkanes from alcohol is considered, this is supposed to be one of the best methods for preparation of haloalkanes, in which pyridine neutralizes HCl and sulfur dioxide escapes out as a gas. Now, just see this example, such as ethyl alcohol. When you have to thionyl chloride, it will result in the formation of ethyl chloride, sulfur dioxide and HCl. So, first was by reaction with halogen acids. Then second, when thionyl chloride act on alcohols. And C part from alcohol will be when alcohols are made to react with PCl5. So, alcohol when react with PCl5, it will result in the formation of alkyl chloride RCl plus POCl3 plus HCl will be given out over here. These three reactions we have written over here. When we will discuss the chapter alcohol, this will become the property of alcohol. Over here, these are the method of preparation of haloalkanes. So, how many methods we have done by now? First one was from alkane, second was from alkenes, third was from alcohols. And the fourth method is a halide exchange reaction, which is again very important concept. This method is normally used for the preparation of alkyl iodide. For the preparation of alkyl iodide. And when it is used for the preparation of alkyl iodide, this reaction is called as a Finkelstein reaction. What is to be done? Here we take alkyl chloride. It is made to react with sodium iodide. Iodo group will substitute the chloro group and will result in the formation of alkyl iodide and sodium chloride. This particular reaction is known as the Finkelstein reaction. The reaction is being carried out in presence of acetone. Now, what is the function of acetone? Acetone will precipitate out sodium chloride and hence will shift the reaction in the forward direction. So, you must learn what is a Finkelstein reaction. You must know what is a Lucas reagent. Lucas reagent is a mixture of anhydrous zinc chloride and concentrated HCl over here. And concentrated HCl over here. Now, by this halide exchange reaction, fluoro compounds cannot be prepared, as fluoro compounds are highly violent. So, fluoro compounds are prepared by the reaction which is called as a Schwarz reaction. In Schwarz reaction, what is done? Alkyl halides are treated with metallic fluoride such as methyl bromide. When react with AgF, it will result in the formation of methyl fluoride and AgBr. So, what reaction is this? It is a Schwarz reaction. Or by treatment with mercurous chloride, it will result in the formation of methyl fluoride over here. So, fluoro compound can be prepared by the Schwarz reaction. Iodo compound can be prepared by the Finkelstein reaction. To word coming question in the board examination, they will be asking, what is a Finkelstein reaction? What is a Schwarz reaction over here? And then a very simple concept has been applied over here. From alkane, when haloalkanes are prepared, the mechanism will be free radical substitution reaction mechanism. From alkenes, when haloalkanes are prepared, mechanism will be electrophilic addition reaction. However, in presence of peroxide, mechanism will be free radical addition reaction and it will be the anti-Markovnikov rule. These two reactions we have also done, that is the preparation of allylic halides by allylic substitution reaction, such as propene when react with chlorine, it will result in the formation of allyl chloride. Propene when treated with NBS, it will result in the formation of allyl bromide. And then from alcohol, mechanism was nucleophilic substitution reaction. Intermediate is carbocation, the details of which will be discussed in the further part of the chapters. And then by halide exchange reaction, which is called as a Finkelstein reaction. And then the preparation of fluoroalkanes, which is a Schwarz reaction. If you have concentrated on this video lecture, method of preparation number 1 from alkane and from alkenes, they were done in the class 11th. By allylic substitution reaction, they were also done in the class 11th. So what new method we have prepared, discussed over here from alcohol and by halide exchange reaction. Alcohol will follow a nucleophilic substitution reaction. 3 cases over here: by reaction with halogen acid, by reaction with thionyl chloride, and by reaction with PCl5. Now, which is the best method of this? By reaction with thionyl chloride, then by halide exchange, Finkelstein reaction, and Schwarz reaction. Hopefully, you understand the preparation of haloalkanes in this part A of our lecture number 5.